The last function in our library is the first one we discussed in the class, the absolute value function. Like the linear functions, our example here is really the only example that we need of an absolute value function. Everything else that goes into making up more complicated absolute value functions is all linear. The domain of this function is all real numbers, and what the absolute value does is it takes any real number and it turns it into its positive version. So its range is the positive real numbers, including 0. This is not a one-to-one function, which is one of the reasons that we met it. And so it doesn't have an inverse. We faked an inverse to it by splitting the domain. Unlike the even power functions, once we split the domain, there's nothing else to do. Because it removes the sign information, this is again an even function. It has no asymptotes, and when we go to graph it, we'll use the points -1, 1, 0, 0, and 1, 1. Like with linear functions, we'll sometimes get slightly clever with the points so that we can get integer pairs to graph. So instead of 1, 1, we might choose 2, 2, or 3, 3. Or equivalently, we might mess around with our multiplication to understand part of our scaling as horizontal and part as vertical. Now, the absolute value is kind of an oddball function. It's in this sort of category by itself, and yet it has a lot in common with the power functions. In fact, we can see it as part of that family. We can think of the absolute value as being the result of squaring some real number, and then taking the square root.